morning. Planet Tech. We left saving the world till the last day of the Web Summit, but good on you for turning up. We are down to talk about a new way of doing science. So there's lots of super brainy people out there in the universities and in R&D units who are doing amazing work to counter the climate threat that is very real. It's here on our doorstep. But there's other brainy people that outside that trammeled research that also need funding, that have great ideas, but need to get them off the ground. And our two speakers today, that's their passion, is looking at different ways of doing science, getting those ideas out there, getting them to scale. So it's super exciting at this timely time where, we need answers. The problems are big. The timeline is short. Deborah, maybe we could kick off with you. This question of new voices in science, why are they important? What's wrong with just bunging 100 million to Stanford or to Cambridge and asking them to sort it out for us?
Doing business as usual, you mean? So you articulated it well. The problems our planet are facing, climate change, energy crisis, food security, are huge existential threats to our own survival, let alone the planet's. And the way we've traditionally done science is we fund universities. Becoming a scientist is a long apprentice process. You may be in your late 30s to 40s before you have the position and the funding to be able to address the kind of questions that you're interested in and at the scale that we need them. Start of a project to publication is 5 to 7 years. 5 to 7 years, we are so out of time right now with climate change and trying to keep carbon down. So we can either continue business as usual and we will not actually succeed in addressing these issues, or we have to step back, and I think we're starting to see this now, and say, look, there are an enormous wealth of people out there, young people with incredible talent. You only have to walk through the halls here and you can see it, you can see the innovation. And yet we are not giving them the platform and the support they need to come out with these solutions. So we need to amplify the young voices. We actually need to disrupt the old model of academia, which I love. I came through academia, and start to find new platforms. And I see that happening already, that the models that are emerging are different kinds of ecosystems, different ways that scientists and innovators and funders are coming together to start to amplify these new voices. We absolutely urgently need it.
So this is alongside traditional science. You're not replacing traditional science, so the universities and the R&D labs will continue.
Yeah, the universities will continue, and they need to continue that way of doing science. It's leisurely, it's a slower process, and it brings value. But in addition to that, we need these new kinds of models that bring scientists forward, particularly young scientists, and it will not be in academia. I would say that in the next 10 to 20 years, we will not see academia leading the innovations or leading the change. It's going to come from other sectors, it's going to come from other groups, some of them yet to be formed.
That's fascinating you're saying that as someone that holds a PhD in marine science, that it's actually not going to be the well-funded academic departments. The Footprint Coalition, you're working to support these new brains. I think the phrase you use is high-risk, high-reward projects, often young people. Tell us a bit about the kind of people you're looking to support and the support that you offer them.
Yeah, can you hear me okay?
No. I think this is the universities hijacking us to keep their funding.
Great.
How's this? Okay, great.
Much better.
So Footprint Coalition was started in 2019 by Robert Downey Jr. to accelerate the adoption of solutions for the planet in the realm of climate change mitigation, adaptation, and planetary restoration. So we've got a three-pronged organization. It has venture capital, it has media, and it has nonprofit, which I do. And the nonprofit arm works with Experiment Foundation, which is a platform, experiment.com, you may have seen. We built a science engine together to be able to fast grant seed fund plus public crowdfunding some of these new ideas in environmental technology. And environmental technology is exactly what the Footprint Coalition is doing in all of these different aspects. So it kind of works like this. There's Footprint Coalition seed funding 50 to 100K, and anyone could do it theoretically, any foundation or company could seed fund a new category of environmental tech. And we have 7 right now. So we have cellular agriculture, conservation biotech, indigenous futures, environmental justice, meta science, mycological innovation, and a new one that we're announcing today at Web Summit is negative emissions technologies. So that will launch moments after we leave here. And basically, in phase 1, scientists can apply directly for $5,000 to $10,000, and these are early career researchers usually. It takes about 2 pages of work, and in phase 2, basically there's a science lead, an esteemed scientist who runs that category that the person is working in, and that person acts like an angel investor and says yes at their discretion, and they push a button, and our seed funding comes through at 50% of the budget. So 50% complete to start, and then we all work together with our storytelling arm to make sure the crowd funds the rest. So it's building community and transparency as it functions. And then phase 3 is go research, and the whole thing kind of takes only between 2 weeks and 3 months to execute.
That's the second part of my question. What support do you offer? But the first part, who are you looking to support? Who are the kind of people that need 5-10 grand just to get an idea off the ground?
Sure, and there is sort of this conception that science costs a lot of money, and we have constructs that have sort of created it to a system that fosters that idea. But actually, a lot of people who are early career researchers in these fields that are burgeoning and haven't been, gotten a lot of traction and momentum yet from traditional funding, a lot of those people who are working in those fields just need either finishing funds for something they've been working on, something that's adjacent to their work that is not in their main grant. And even actually through our platform, people who are citizen scientists can participate. So great ideas can come from anywhere, and the stories that we want to tell about what people are working on is all solutions-based. So we're accepting anyone from around the world to do this science, and they can be at any level, but usually early career researchers in academic institutions.
So they could be in a garage. They don't need to be
Totally.
on an academic program, or they could be in a business.
Yeah.
Okay.
Yes, and I think that's a great aspect of our organization structure, is that it can be a continuum between the early research, commercialization, and scale. And we have the capacity to invest in those things later that succeed, that are the high-risk, high-reward ideas.
Just on the negative emissions technologies, this thing you've announced today, I'm thinking of those big carbon capture storage projects. I mean, these are multi-million-pound geoengineering type ideas. Am I right? Like, how can a 50 grand...
Well, actually, it's a combo. There's 2 science leads for that one, because one of them, Paul Reginato, is doing biological methods for atmospheric carbon reduction, and Merritt Daly, the other scientist, she's doing industrial methods. So there will be a lot of folks who are working on efficiencies, small-scale prototypes, things that are atmospheric carbon reduction technologies that are very new, and a lot of those can be tested, and basic hypotheses that are part of the bigger whole can be tested for that kind of money.
Brilliant.
Yeah.
Deborah, maybe you could give us an idea of, we talked about the potential that this approach to science can have, but you've been working in the field for 25 plus years, I know in the Caribbean in particular. Maybe you could give us a flavor of how these things look in practice, how this alternative approach, more dynamic approach.
Yeah, absolutely. So we've been working on, my background's in marine science, and so nature often holds a solution to a lot of the challenges we're facing, and when we marry nature with new technologies, we can really accelerate the way we get to these solutions. So I'm going to give you one example. Climate change and addressing climate change. We know that, for instance, mangrove forests and wetlands sequester 4 times more carbon than even tropical rainforests. Coral reefs, which are tropical in tropical oceans, healthy coral reef will break 95% of a wave's energy, meaning that you don't get as much storm surge on the coast. It protects the beaches, and it protects the communities that live along the coastline. On top of that, coral reefs have 25% of the world's biodiversity. They support 500 million people directly every day. But we are now losing coral reefs. Tom Chi from Google was telling me that we lose more reefs in a day than we can restore in a decade right now. So that is a huge loss for the planet. It's a huge loss for these ecosystem services. So about a year and a half ago, my business partner, John Paul DeJoria, and I were working in Antigua and Barbuda, and we got to talk about these issues and the fact that the restoration process is going really slowly. There's a lot of very good science out there, but the process is slow. So we pulled together modelers, engineers, ecosystem scientists, coral reef scientists, and literally came up with a reef design that provides all of these services I talked about. The architecture of the reef, the habitats, the breaking of wave energies, the provision of biodiversity. And earlier this year, we deployed the first set of these modules that we're testing. Last year here, I made an announcement and said, look, we'd love to try some new AI technology. As a result, we had Nature Counts Foundation come up. They are developing these cameras that we now have deployed on our new reefs that are recording 24/7 the kind of biodiversity, the changes we're seeing, the structure of the reefs. I am getting in a month the kind of data it would take me a year to get. And we're already using these data that have come in, now doing machine learning, to design our second set of reefs that we will deploy probably at the beginning of the new year. So this all took a year and a half from start to where we are right now, one already deployed. And what we've decided to do next is we're now going to build a center for innovation. So we will have a platform. We're working with the government. We have an underwater platform. So anybody who has a technology, who would like to test it, who would like to deploy it, please come and talk to me. We have a platform for you. We have a way of being able to start to initiate these kind of studies and then to scale them up to other areas in other parts of the world. So that's what we're doing.
That's a center for AI technology looking at marine science.
It's not just AI technology.
Okay.
It's basically the kind of innovations. Maybe it's remote sensing. Maybe I was talking to somebody who's looking at an immediate DNA type analysis that you can do in situ. So there's many of these new innovations that people are really coming up with today, young people are developing, that do not, it's very hard to get them actually into the water. It's very hard to get them into the field where they can be tested and where the actual real data are coming back. And it's for that kind of innovation.
Got you. Okay. But just very briefly, you said right up front that it takes 5 to 7 years for a formal science project to sort of see its way through. And this has been a year and a half, I think you said.
Yeah, we're a year and a half.
You've got the AI bit doing a lot of the hard work that you would have had scientists doing in the past. But how have you accelerated so quickly? What tricks might we learn about getting these projects off the ground?
I think several. We partnered with government, we partnered with philanthropists, we partnered with business people, people who are used to saying, what is the problem and how do I solve it? Then we went out and we found the best and the brightest people who were doing these kind of studies in science and said, we'd like to engage you, but here's our time frame. Can you find us a solution? Can you do this in a month or 2 months and give us the answer? And what we found was that the people we asked, who often some of them working in traditional academia, others in industry, went, you want this when? Oh my God, I'm so excited. Yes, absolutely. I've been waiting for somebody to ask me this question. So the energy to do it is out there. The ability to do it is out there. The solutions are out there.
Yeah.
So it's really creating this new ecosystem of like a community that we never thought we'd have together.
Yeah. So you put a call out to the best and the brightest.
Yeah.
In this audience, we're going to have for sure, some of the best and the brightest people with good ideas. They're looking to development, commercial propositions. Rachel, I mean, you're familiar with that kind of person, and other than coming to you and asking, for some of your seed funding and to get off the ground, what kind of advice would you give someone sitting there with a brilliant idea, tech-based idea for climate or ocean solutions? What are the do's and perhaps what's the don't?
Well, of course, I mean, I would just, before we kind of move past it, if you're interested and passionate about a particular environmental technology category and you do want to fund one of these, you absolutely can. It's very little money. And also, even just funding one project, you can go to footprintcoalition.com under Science Engine and fund one project, and it might change the course of history. Who knows? I think what we want to continue doing, though, is pushing the boundaries of science funding in general. It's important to support the people who have the most factual information about the crises that we're going through in climate change and biodiversity. And there are ways, focused research organizations are one, prizes are another one, what we're doing is a third. There's a lot, and I think it continues to be very important to figure out ways to get people engaged in the fight that have tools. We're also doing some advocacy projects on the media side, so trying to get people involved and focused on what policies they can support, what initiatives, what campaigns with different nonprofit organizations are doing, how they can find jobs in different climate tech companies. So there's a lot of ways that we're talking about supporting that are non-monetary, but I think it's very important that we think about how to remove red tape for people who really are working on these solution sets.
Could you give us an example of Footprint Coalition has supported lots of different scientists and
Yeah.
small businesses, one that really captures what you're trying to do, that inspires you?
Sure. So I'll give you maybe a couple. There's a group that's out of Carnegie Mellon that is 3D printing Wagyu steak. And I think people have heard about this a lot, cellular agriculture, but the difference here is these young scientists have figured out a way to convert a normal desktop 3D printer to use a filament that's made of cell cultures and print a steak and its scaffolding into a small apparatus that could potentially be replicated, infinitely. So you might be able to, in very short order, have a way to produce a steak in your own home, just with having a supply of this filament and deciding that you program in exactly what you want and you want to be able to print it and eat it. So something like that. But we also have people working on understanding the indigenous microbiome of indigenous managed lands and their soil. We have a person who's sustainably mining rare earth elements using microorganisms. We have a couple people who are working on other cellular agriculture things, growing cotton without the plants, digesting textile waste with mycelium. And there will be no end to sort of what the projects will look like, I think, because people's imagination is limitless.
Yeah.
So
That's the upside of working with the best and the brightest, right? They
Right.
come up with all sorts of ideas.
They do.
This is flashing. We've got 1 minute left. COP is just a week away. Lots of policy makers are going to be going there with their high-level kind of pathways and interventions and ideas for how we're going to solve climate change and keep temperatures below that 1.5 degrees. If you could go with a science minister and communicate one message at this COP meeting, what would it be? And we've got 30 seconds, so maybe 10 seconds each.
I'll just be quick. Take risks. We need to try a lot of different things quickly in order to get our goals done in the time that we have left.
Mine would be take action. Stop talking, take action.
Take risks, take action. Brilliant. Thank you so much. Thank
Yeah.
you all.
Thank you.